So the big picture for this lesson is absolute value of complex numbers and complex numbers in trigonometric form. So the absolute value of a complex number is the distance that number is from the origin on the coordinate plane. Remember that when you plot a complex number, you have the real axis, which is horizontal, and the imaginary axis, which is vertical. So here's an example of a complex number plotted, 4 minus 2i. You can see it here. And what you do is you use the Pythagorean theorem to find out the hypotenuse of the triangle, and that tells you the absolute value. So in this case, the 4 is the real part, the 2 is the imaginary part, so the absolute value is the square root of 4 squared plus 2 squared, which is the square root of 20, or 2 square roots of 5. So that's how you find the absolute value. Now, trig form of a complex number is also called polar form. It is determined by the radius and the angle measure in radians. And polar form in general is r cosine of theta plus I sine of theta. So the real part is cosine, the imaginary part is sine. And that should make sense because cosine is typically the horizontal component, which is the reals, and sine is the vertical component, which is the imaginary. So here's an example of writing a number in trigonometric form or polar form. First, what you do is you kind of plot the point and then draw out a triangle like this, and it's in quadrant 1 because both signs, the real and imaginary, are positive. Then you calculate the absolute value using the real component and the imaginary component. In this case, it's the square root of 3 square roots of 3 squared plus 3 squared, and that works out to be exactly 6. So the radius is 6. Then you need to find theta, and what you do is you use inverse tangent, because you have the b and the a, which are the imaginary and the real. You divide those, and then tangent of theta is going to equal that ratio. In this case, it's square root of 3 over 3. So you do the inverse tangent of that, and you get exactly pi over 6. And because it's in quadrant 1, both signs stay positive for the cosine and the sine. Since it is quadrant 1, this is not only the reference angle, this is the actual angle. So you use pi over 6 in the trigonometric form, and then the 6 is the radius. So it's written as 6 cosine pi over 6 plus I sine pi over 6. So that's the big picture for this lesson.